Hey guys, welcome to another episode of Let's Make a Game. In this episode, what my idea is to start converting some things over to help us set ourselves up for our physics and our collisions and all this sort of stuff. And one of the main things we want to do is take how we track position, and we could also use this for velocity or anything like that. Instead of having them be individual interfloats, we'll make a vector class that will store those values for us, and that we can access from whatever has a vector within it. So it would be a new way of handling positioning that'll also ease our calculations when we do velocity and when we apply physics to our game. So let's get started. Just gonna check comments real quick, make sure everyone's good. Yeah, looks like it. So, okay, great. So the first thing we're gonna do is, so for example, if you look at a sprite class, right, we have xpos, ypos, x scale, y scales, two separate values. This is exactly what I'm talking about. We're gonna want to change these so that we're actually tracking them as one value that is of type vector instead of float. So let's create a new vector class. And it doesn't really fit into any of these folders, so we'll create a new folder here. We'll call it math, because this is we're gonna be putting some of our math classes and functions. So in here, we will create a new vector, and let's call it a vector 3, just to signify that there's 3 values. And I know we're only dealing with 2 dimensions, but this is going to be a class that we can then use if we ever choose to do anything in 3 dimensions. So we'll create a vector 3.cpp and a vector 3.h. And again, start. Oops. There we go. Okay, great. So what signifies a vector? A vector is it's one entity that will hold 3 values for us, usually representing x, y, and z. We could also use this for other things, like I guess we could use it for color, right? RGB, anything else that comes in 3s, or even in 2s, right? If since we're really not going to be using any of the z here, it's mostly just going to be 0 on the z. So we're really only going to be using it for x and y. But again, we want to set ourselves up for something that we can use, and it's in a more wide range of applications. So vector 3 is going to have 3 things in here, and so this private section, I was thinking about it, right? Because if we make our member variables just like every other class, we make like float x, float y, float z. If we make them private, then we need to make getters, and I'm just trying to think of like what this would look like, right? Because if we look at our, for example, our sprite class, instead of having xpos, ypos, if we had a vector 3, oops, called pos, just position, and obviously it's not going to work for now, but if we had that, then in here, for example, when we try to get the xpos and ypos, we'd have to do something like pos.getx and pos.getY, or things like that. But I'm trying to think, like, if the point of this is supposed to be to replace these guys, then we really shouldn't have to make any getters. So I think in this case, I'm going to make everything public. And because vector 3, it's not going to define any bounds, it's not going to need to do any input checking, anything like that. These are literally just, it's a way of accessing these variables in a grouped sort of way, but no different than if they were regular floats, individual floats in the other class. So I'm going to make them all public, and we're going to start. So we'll do vector 3, we'll have a default constructor, and I'm trying to think, because the way you can use these, we're trying to basically mimic what a single float can do, right? So I can say float x, right? I can say x equals y if y is another float, right? So we're going to want to overload some operators here. Now the way we do that, and we'll probably create some more constructors once we kind of have at least our operators fleshed out. or actually, I guess, because we could just do this, something like this, right? Vector 3 float x. If you want to initialize it with one value, that will go to all three. Otherwise, we need float. Oh, and this would be underscore x, float underscore y, float underscore z. So we can initialize it with nothing, and we'll probably just set everything to 0. Here we'll set all of the values to this one value, and here we'll set each value individually, independent of any other. There's also one more constructor we can add, and it looks like this: vector 3 taking a const vector 3 reference called other. We're going to use a lot of these const references here as well when we do our overloaded operators. This basically means that I could say vector 3 pause and then just pass in another vector, like a velocity vector for whatever reason, and we can just initialize it to the value of another vector directly. So yeah, we'll do that. Okay, so I think that's it for our constructors. We can also do our overloaded operators now. So we're going to overload, let's see, equal sign, plus sign, minus sign, multiplication sign, division sign. Actually, I guess that's it. Yeah, that sounds about right. So these are all very specific in the way we have to write them. So for example, the equal sign is the only one that's different from any other overloaded operator. So in this case, we're going to go vector 3 reference. We're going to return a reference to a vector 3, and we're going to call the operator equal sign. I'm going to pass in a const vector 3 reference called other. Okay, and as you can see, that is good now, and obviously just can't find the implementation of this yet, but this is basically what that pause equals vel is going to do. This is the operator we're overloading. We're passing in vel as a const vector 3 reference called other in this case, and we're returning a vector 3 reference, which we're going to then be setting to our pause value. Okay, so that's our operator equals. Then we'll go vector 3 operator plus. Now, yeah, because the equal sign actually changes what's on the left-hand side, right? We go pause equals vel. The equal sign actually changes the value of this, which is why we return that reference to. That's the only operator that does that, which is why it's the only one that returns a reference to. Because if we do something like pause plus vel, that just gives us a brand new vector 3 to work with, but we then need to go ahead and say like new pause equals pause plus vel. This gets calculated into its own vector, and then we call our equals operator to then set it equal to our new pause, given that all these are vector 3s. And this is exactly how any other equal sign operator works, right? You can say 1 plus 1. That's only going to give you 2, but it's useless unless you say x equals 1 plus 1. X being an int or a float or whatever it may be, it's going to calculate this first and then take that calculation, the result of it, and give us back a reference to that we can then store in our variable here. So that is why we only return a reference to a vector 3 when we do the equal sign operator. The other operators are going to be like this, and they're all going to take vector 3 references. Oops, vector 3 references called other. So this is the plus, minus, multiply, and divide. Minus, multiply. And actually, I wonder if we want to do a divide. We could, and then we'd divide like, because I'm trying to think, like, if z is going to be always 0, for example, then every time we want to divide like the x or the y, we can't divide by 0. So maybe what we could do is just like multiply by 1 over whatever the value we want in here and do it that way, and then at the end we'll just do a 0 to multiply by 0. So we'll probably end up doing that, but what this would do is this would mean that we would have to multiply by another vector. We could also overload the multiply operator again and just pass in a float and multiply by all, and then in this case when we overload it, when we actually write the code, it'll multiply each value independently by this value. So yeah, I think I like this. I think we're going to stay away from the dividing just because of that divide by 0 case, which we can always check. I guess we could just check it. How about this? Let's leave it as is, and we'll write it if we need to use it. Otherwise, we'll tend to just multiply by things. Okay, so then, okay, so those are the only operators that I can think of that will give us new vector. But you also have something like this, right? Like x equals y. That's also an operator that we need to overload if we want to check if vectors are equal to or not equal to each other. For whatever reason we may want to use them for, right? So we can also do those. Now those operators return bools, right? Because they'll either be true or false if they're equal to or not equal to. And then we'll have operator equal, so double equal sign, and that'll also take a const vector 3 reference called other, and the not equal. It's the exact same, just not equal. It's just basically, this would probably actually end up just calling this guy and returning the not of it, so we don't have to do the work twice. And yeah, that's pretty much it, I think. Yeah, and if we ever need to add more, we can always come back here and add them. Okay, so now that we've got these guys, we can go into our vector3.cpp. We'll include vector3, and then we can just go ahead and get started on actually implementing these. So the first thing we're going to do is our constructors. So vector3. We have a default constructor. We're just going to set x equals 0, y equals 0, z equals 0. That's the default constructor, vector3 taking in, what was the other one, const vector3 reference other. In this case, again, we just want to basically copy whatever's in here. This is called a copy constructor because that's exactly what it does. It copies everything about this other into our current instance of the class. So we basically just say x equals other.x. And because it's public, I can actually access it like this with the .x, which is neat. I think I like that better than running the getters and setters for these guys. So that's x, y equals other.y, z equals other.z. That's it for that guy. And then next one, vector3. Vector3 takes a float underscore x. Then we'll say x equals underscore x. Oops. And do the same for y and for z. So that's this guy, and then we have one more, I think, vector3 takes 3 floats. And then x equals underscore x, y equals underscore y, z equals underscore z. So yep, 1, 2, 3, 4. I think that's it for our constructors. They're all good. Now our operators. So our operators will look like this. So vector3 reference for our equal sign operator, right? Then vector3 operator equal const vector3 reference called other, and there we go. So now what this guy's going to do is, again, because he's an equal sign operator, which means you set a value of something, that's where we basically want to set the current values. So we can do something like x equals other dot x, y equals other dot y, and z equals other dot z. But and this is fine because we set it equal to, but remember we still have to return a reference to a vector3. That's the way we have to overload these operators, for at least the equal sign one. So obviously we just want to like return a reference to ourselves. So you can do that by returning a dereferenced version of this, and this is a pointer to our own instance of this class. And when we dereference it, we give back the actual value, which they can take in as a reference. And then that way we set the values here and we return a reference to this particular vector3. So other than that, that should be good for this guy. And we have vector3, and it just returns a vector3, a new vector3. Vector3 operator plus takes a const vector3 reference called other, and in this case we're just adding all the values together, right? So now, well, in this case, so we're not supposed to be modifying this current instance, right? Because we're returning a new vector3. Again, pos plus val shouldn't actually modify pos, right? It should return a new vector3 that is the answer to this question, but pos plus val. So we shouldn't actually modify anything in pos. So we're not going to say x equals anything. We're going to create a new vector3 called like ret for return, or return value, whatever. And then we'll say ret.x equals other .x. And actually, I'm thinking about this now. We have a constructor for this right here, copy constructor. So we already have this here, so we can just say ret and pass in the other, and that will use our copy constructor. So now this code executes given this other on this ret, and then we can just return ret. So very simple. That actually works. Oh wait a minute, sorry. What? No, sorry, I think I get confused. Yeah. So this is just going to return this. We're not actually doing any addition. Again, pos plus vel. We don't want to change the value of this, but we still want to use the value of this when determining what the result's going to be. So, sorry, let me just backtrack here a bit. Yes, we are returning ret, and in this case we'll say ret.x equals x plus other .x. I think that makes more sense. So we're setting this equal to the current x plus the other guy's x, and we'll do the same for y and z. And then we can return ret. There we go. So now we're actually adding the values together, storing them in a new vector3 that we then return. Yeah, that makes more sense. So then we'll do the same thing for minus, and instead of adding them all, we're just going to subtract everything. Oops. Subtract them all. Then we can do the same for the multiply. I think our multiplication is the same, except we have the second one as well. So we have yes. We don't have to do this yet, and then this, and then these two. All right, cool. So the multiplication one, we're just going to multiply everything. Yeah, that sounds good. And then vector3, well, I guess it'll be very similar, except instead of a const vector3 reference, we're going to pass in a float called _x. And sorry, this is multiplication still. And then we'll say x, where each individual one will multiply by _x. So that'll be x times the value, y times the value, z times the same value. Yep, I think that looks good. So that should be it for our, for these guys. Now we need these two, and then we should be good with our vector3 class. So for these two, they're going to return bools, vector3, operator equals, and you're going to take a const vector3 reference called other. And here's where we basically just want to return if all three values are the same, right? We want to equalize, we're checking equal sign on all three different values. So we can actually pull this all together instead of, like, we could do an if statement, like if x equals other.x and y equals other.y and z equals other.z. So this should give us, if it's true, we return true. If it's false, we return false. So instead of doing like this, so this will work perfectly fine. Oh, wait a minute. X. That's weird. Modifiable L value. I think it's confused. I'm checking equals. Like this is just a float. X equals other.x. And other is just a run the vector3. I think it's confused. Let me comment this out and build this. Oops. Looks like it's a real. Oh, geez. Okay, got lots of warnings. Doubles to floats. All right. Oh, this is Sprite. We're gonna fix that. But yeah, up here we failed. equal, it's just taking a single equal sign, forcing value x equals other dot x, and y equals other dot y. Oh, well, jeez. See, that's alright, anyways, so sorry about that, guys. So z equals other dot z. That's weird that it put it up here, but anyways. So yeah, so the idea here is that, you know, we can write it a whole if statement and return true or false either way, but this itself is going to be true if we want to return true. So we can actually just return this. And this is pretty much straight up just going to say, calculate this. It's going to be either true or false, because we're ANDing them all together, and then just return that. So if this is all true, then we want to return true. Otherwise, we want to return false. So yeah, so we'll do that, and then bool vector3 operator does not equal. We'll take a const vector3 reference called other, and like I said earlier, right? Geez, vector3 is operator not equal. Oh yeah, that's right. So like I said before, right? Instead of like rewriting this and putting like a not up here, we can just call this guy, right? We can easily just say return, and we can call our function operator equal and pass in other. There's nothing wrong with doing that. And then at the front, we'll just say not. So this is, it's just calling another function. Just because it happens to be an operator doesn't mean we can't call it as a function within its own class, right? So we're going to call this operator, pass in the same guy, return whatever value they are, but then not it before we return it. And that will give us the not equal. So that should be good. I think we're good to go. Let's F7. Yep, we look good. Vector3, great. So I think we're good to go in terms of the class here. So I'm going to close those guys, and then wherever we use and like modify x and y positions like this, we want to basically turn these into vectors, or vector3s rather. So in here, see how I did this. Yeah, no, these are all good. Okay, yeah, this. So I just wanted to make sure that we're still using this. That's fine. We can, because this is all our own engine code. We're not worried about anybody else moving things around, so we should be okay. It's probably not best practice, but for the purposes of this tutorial series, we're probably just gonna leave it like this. So now we do include // and instead of going to engine, we go to math and we'll include vector3. Now actually this will have to happen in the .h here, like so. And instead of these two guys, we're going to want to do vector3 pause, just like that. Same with the scale. Vector3 scale. Rotation obviously is going to stay float. I tend to group things together, but I think this makes more sense. Usually pause, rot, and scale. Alright, that's fine. Okay, so, alright, so here we go. So we're giving it an initial position here. Instead of taking two floats, we'll just take a vector. Vector3 called _pause. And yes, we're going to have to change a lot of code on the other side, but it'll be worth it. So then speed to, speed by should be fine. Move to, move by. We probably want to do vector3s for these guys as well. So vector3, call it x, I guess. It's confusing. Let's do vector3 vec, I guess, or just v is fine. V for vector, vector3 v. So move to, move by, they're both going to be vector3s that we can specify an absolute position or a relative position, both with vector3s. Rotate 2s are fine there. Set scale, that should be fine. Well, in fact, yeah, actually, I'm going to, okay, I think we'll leave this guy because I don't want to have to create a vector3 just to pass in a single value. But for this guy, I think I'll do a vector3. V. So, okay. So now this is actually telling us which ones we have to change. So we'll go over to here, and yeah, we'll see right away. So instead of these guys, we just want to do pause, and then we can just pass in 0, I guess, right? Oh, right. So sorry, we're not actually creating one. So we can say pause equals vector3 0, just like that. Same here, and here. Well, actually, here we're passing in a vector 3, so we want to go vector 3 v, and here's our copy constructor, right? So we are actually just our equal sign. We can say pos equals v, and that's it. So this is the beauty of overloading these operators here, right? So we do that. Here we'll have, so here's where I didn't want to use the getters, and I didn't want to have to call setters every time I wanted to change the values either, right? So here we can just say pos.x, and here we say pos.y. And it may seem like a minimal change right now, but it's going to be worth it when we get into actual math with vector math and things like that when it comes to our physics side of things. So here we'll go scale.x, and here we'll go scale.y. Move2 now takes a vector 3 called v, and it's just setting the values, so we can just say pos equals v. Move by is adding the values, so we can say vector 3v, and so you can say plus equals, right? So we didn't overload plus equals. We can just say, now this is 2 lines, so I'm going to leave them there for a sec. So we can just say pos equals pos plus, and it's just the same idea as plus equals, and then we're taking those x and y's and multiplying them by the delta time, which we still need to do, but luckily we do have a multiplication operator that we've overloaded that takes a float, which is exactly what this goes, double, but actually this is probably why we got all those warnings here, so we're going to want to cast these guys as well. So we'll say pos equals pos plus, and then v times float engine get dt, just like that. Right, so now this is saying take v, multiply it by the delta time, so that'll multiply both x and y by the delta time, same thing we were doing here, and then assign it to pos after adding itself to it, so it's same as the plus equals. So that should do it, and then this cast here for float should remove our warning. Move left, so we're minus equaling, so again pos equals pos minus speed times engine get dt. And again, this is just a float, multiply, oh yeah, we gotta cast it to a float, multiply float by a float, and then we're subtracting, oh, can we do that? Do we have subtracting by a float in our vector? Subtract by a full, we have it by an entire, yeah, so we actually might want to do this for everything else too, right? In case we want to add the same amount to both. Oh, well, wait a minute. No, yeah, actually this is different because move left is only going to change the x pos. So, okay, so here's what we can do. So pos equals pos minus, and then we'll create a vector 3 with this being the x and 0 for the y and 0 for the z. Right? So that should subtract this much from our x position and not affect the y and the z. And we'll do it that way. I think that makes sense. Then move right is the same thing, but we're adding that much. Move up is the same thing, but it's on the y. So adding to the y. So adding to 0, 0 for the x, there's for the y, and 0 for the z. Let's move up, and then move down is subtracting from the y. So we'll subtract from the y. Yeah, that should do it for these guys. And we'll make sure that this all still works properly, and it looks good. Rotate is fine, and set scale again. So scale equals x. And do we have that overloader operator? I don't think we do actually. The equal sign still takes a whole other. Yeah, we could add the equal sign for a float, and it takes a float in. I'm just thinking like if we want to keep z as 0, then we're gonna have to. Then we're gonna do like. We're not doing equals a float, but then we're gonna kill the 0 afterwards in 2 lines of code. So I think it makes more sense to just say vector 3 x 0, right? I think that makes sense. So that way the 0 stays as, or this stays as 0. Except for scale, we might want a 1. Okay, let's leave it like. Well, let's just pass in x. Should be fine. That z value isn't really gonna affect us in this case. And this is a 2D sprite, so I think we're okay. And then here, set scale, we pass in a vector 3v, And here we're set. So here's where we can basically just say scale equals v, and that way our x will be copied over, our y will be copied over, our z will be copied over. So we should be okay here. Looks like we're good. Let's build this. Oh, and actually, yeah, we're gonna have to change some things. Where's that error? Here we go. Yeah, okay, so like things like this, right? So actually, I think it's probably the only place it happens, but we'll do vector 3, and here we can pass in a single float or another vector 3 or 3 separate floats. So we can do 100, 100, 0, just to use a vector 3 there. I think that's the only time we actually use that. And yeah, it looks like we're good. Expected a new line. Oh, weird. Other than that, okay, let's go ahead and fix these two. Oh yeah, so get width returns an int, but this is a float, so yeah, we'll have to convert this to a float. Yeah, float, float, and float, and float. Is that the only place? Plus equals, rotate by. So this is, yeah, so again, float. Okay, I think we're good. See, this makes me just want to actually change it in the engine itself. And you know what? I think I'm gonna do that because I don't want to keep casting it. If we're only gonna work with floats, then we'll return the float. We'll store it as a double, but we'll return it as a float. So I want to store it as a double, so we get that precision. I mean, not like it matters if we're gonna convert it to a float anyways, right? Yeah, we might as well use float for everything. So let's switch this guy to a float and this guy to a float. And this guy to a float. I think that should be all we have to do. Everything else should, oh, got this guy. Float. Alright, I think that's better. I think it makes more sense for us. And then in here, we just remove these. Okay, I think that's the only place we actually do that. These guys are still returning ints, which is fine because that's coming directly from the texture. And you can have a texture with half a pixel extra for width or whatever. So we will have to convert these, and that's fine. Unless we have like 2i, or even just 2. I wonder if that, no, do we have 2i for ints? Oh, we do. Alright, let's, takes GL ints. Yeah, okay, so let's just use those. Because these are always going to be ints. Let's remove those. Okay, cool. Yeah, I like that. So now we don't have to cast anything. I think if we have 7, okay, still a couple more. Oh, right, this is why we use doubles. That's fine. Let's just cast this to a float. I hope that's not important. I don't know how precise this gets, how much precision we need for that. I think we're gonna be fine. And here, one last thing. Yeah, again, float. Okay, I think that's it. Let's rebuild everything just to ensure. Project, no, debug. Not debug. There we go. It took me so long to find. Okay, yeah, we're looking good. So let's run it, make sure everything's good still. So we move with WASD. Yep, and look, we started at that 100 by 100. Looks like our delta time still works. Not like I don't think we'd notice any change, even if it was the improper way to do it, but looks like we're okay. Now we're using, nice. Now we're using our vector 3s, which is good. So before I move on, let me just check comments real quick. I'm liking your naming convention. It's good. I hope you're not being sarcastic. I tend to just, what, the underscores, I guess. Let me know exactly what it is you like. Liking your naming convention. Yep, and that's it. That's the only comment we've got, so that's fine. I'll check that up in a bit after. For now, let's move on. So what do we do? So we convert everything to vector threes. So what that's going to help with is when we're dealing with things like velocity. So I think for the rest of the time, what we're going to end up doing is we'll start working on our Rigidbody class, which is going to help with velocity, gravity, basically uh, everything that has to do with a physics body. We won't get into collisions today because that's probably a whole day, but that's fine. We can just get started, and that won't be under math. We create a new one, a new folder. We'll call it physics. Oh, there we go, physics. And then we can create a new class. We'll call it Rigidbody and Rigidbody. Okay. And def which Alright, great. So now we have a Rigidbody class that we can start working on. So the idea here is to separate the physics aspect of our sprite from the actual sprite itself. So again, the sprite, so we have a texture, right? A texture is the image itself that gets loaded and it has information about that image. Our sprite is what takes that image and positions it, rotates it, scales it to the way we want it to be. But that's all it does. It's a method of positioning and displaying this texture in the way that we want. It shouldn't handle physics or anything like that. It should just be its own thing. In case we want, like, for example, a background object that doesn't have any physics related to it, we shouldn't have to deal with all these physics related things just to create a sprite. You know what I mean? So we'll let Sprite do its thing in terms of positioning and rotating and scaling that texture, and something like another class we create can have both a sprite or be a sprite and a rigid body. So we'll define kind of what that other class is going to look like down the road. But for now, we'll have a rigid body here. And now a rigid body, the idea here is to have it work with the sprite. So that, for example, if I move my sprite, I probably don't want to have to say, like, sprite dot move left, and then also do the same thing for my rigid body. Like, my rigid body should be attached to my sprite because my sprite has my positioning, my rotation, all that stuff. So my rigid body should be a part of that sprite. So what I'm getting at is not to have the rigid body be its own thing with its own position and rotation and scale, because really it should be the same as what the user sees. So in order to do that and to ease our coding really to handle the rigid body being at the same location and the same size and rotation as our sprite, what we can do is assign its position and rotation to that of the sprites and have it be updated automatically. And we can do that by creating, instead of vector3 pause, because again, we already have a position, we just want this to be linked to that pause. Or another way, in other words, you can think of it as we want our rigid body to know about the position of our sprite. And in order to do that with minimal work is to make these guys pointers. And yeah, people might get scared of pointers, but pointers are good. Let's include our math vector 3. Yeah, that should be good. So now we have a vector 3 pointer called pause. And this, when we set this guy up, and we'll probably have just a big initialize method that takes all of the pointers and we'll assign them to these guys. So that basically anytime we want to do calculations or we want to update position or whatever, the rigid body is going to handle the math behind it, but it's going to affect our sprite's position and our sprite's rotation and all of that. So that's why we want to do pointers. That way we still render the same sprite, but because we have a rigid body and we call methods on it, we can actually call these, or basically do these calculations away from the sprite, but still in a way that affects the sprite. So we'll have the pause, we'll have the vector 3 size, well, scale, I guess, and the float, rotation, position, rotation, and scale, and then we'll have I guess the Rigidbody specific things now. So again, these guys are just the same as the sprite, but now we're going to need to have our own values here. For example, something like float gravity, right? So how much does this object get affected by gravity? Now, there's two ways of doing gravity in games, or really in anything, right? You can have one global gravitational factor, like one global value that's like 9.8. Every object is affected by it, and based on its mass, it might fall faster or fall slower. That's one way to do it, because if we're going towards the Flappy Bird idea, it's very minimalistic. We really don't need to go that route if it's easier for us to simply give each individual rigid body its own gravitational pull, really. And sure, we can always give it the same value, but if we want to make something heavier, or at least appear heavier, we can give it a greater gravity value, and then it'll fall faster, right? So there's two ways of doing it, whatever works best. I think in this case, because we're just really the only thing that's going to have gravity is our plane in our Flappy Bird game, so I think we're going to be okay with just doing it this way. So we'll have float gravity. We can also have something like float friction, right, which is like drag, right, as you're moving, which we can add in here because, again, our bird is probably not even going to have any friction, but it's good to have it in here so we can actually do the math with it, even if it ends up just being 1, so that you never run out of friction or whatever. And we'll get into that. So that's it. And oh, and I guess we also need vector 3 velocity. And our velocity is going to be affected by our gravity and our friction, and we'll eventually update our position value based on that velocity that gets calculated for that frame. So I think this is it. We have position, rotation, scale, gravity, friction, velocity. So yeah, I think we're good. So let's start with our rigid body constructor, which is going to take nothing. And again, because this is more of something that's supposed to support the sprite, we don't, well, yeah, let's, we'll do this here. We'll initialize everything to nothing. And then we'll have our initialize method. We'll create an initialize method that will pull all of the values and all the data that we need in. That means, what does that mean? That means that somebody could create a rigid body without initializing it and therefore attaching it to anything. So maybe we do want it in here. Oh, but if we want to add this to other classes, or yeah, if we want to add this to other classes, we're gonna need a default constructor anyways. So yeah, I think we're okay with this. Void initialize is fine. Then we can pass in like friction, gravity, and then we can pass in the actual values, right? Because we need to know which pointer we're going to be pointing to. So pause, float, rods, vector 3, sorry, pointer, scale, position, rotation, scale. I think that's it, right? Yeah, I think we're good. Vector 3, sorry. Yeah, I think that's pretty much it. So we're going to have that. And then just like anything else in our game, we're going to have our void update and our void render. Now render, interesting, right? Because render isn't supposed to render anything because our sprite is rendering everything. But we can render, like, debug render our rigid body to ensure it's in the correct place. And this can be helpful for many other things as well. Now this isn't something we would call like in the game, but if we want to debug our rigid body and see where it's actually at, and ensure that it's in the correct position as the as the sprite rotates and grows and things like that, then we can draw lines that will pertain to where this guy thinks he is. Well, I mean, it will always be there unless we assign it to something different, I guess. So that's fine. So we can keep it. And we can even pass in like a specific color to draw this in. Like I'm imagining like lines, right? Just drawing lines from each vertex. Yeah, I think that's okay. And then we can pass in a color, I guess. So vector 3 again. Like I said earlier, we can keep colors in vector 3s. Call it C, and that will just be RGB values, right, instead of X, Y, Z. So I think it's gonna be useful. We'll keep it in and we'll add it. Now the point of, or at least the big deal with rigid bodies right now that we want to focus on is not really, again, the collision stuff yet, but it's more like the physics aspect. So we want to be able to add forces, and we want to, well, actually, I guess that's it, right? So add force. If we want to add a force, pass in a force as vector 3, and we can use that force to modify our velocity, right? So if we add 100 to the x, if we add 100 units of force on the x-axis, then our velocity should increase by 100, and therefore on the next frame our position should increase by 100, and then our velocity will decrease on the x by the friction, and on the y by the gravity. And this is basically how we can keep track of our velocity every frame. Adding one force might affect the position for multiple frames, which is actually exactly what we want, right? So, okay, I think we'll do just add a force for now. And yeah, okay, I guess that's it. So let's go to our rigid body. We'll include rigid body, and then we can start with the actual implementation of a rigid body. So rigid body, and in this case we'll have the friction set to 1. So generally the way I see friction working is like vel.x times equals friction, right? Very simple, but that means that friction is kind of inverted, right? So that means that a friction of 1, so a friction of 0 you might think means no friction, you go on forever, right? But the way the math works, if we multiply that by 0, it's going to be 0, it's going to automatically pull our x. So this actually means full friction. No, it's not like there's like a gradual loss of force or velocity, really. It's just going to set it back equal to 0. Whereas a 1 means we'll take the x velocity, multiply it by a 1, and that way it'll stay the same. So this actually means no friction. And if we wanted to lose half of its speed every frame, we go 0.5 f, right? And then this will lose half of its speed. And yeah, we'll basically do it that way. So anyways, to start, we'll set this to 1, so that way it doesn't lose any velocity. We'll set the gravity equal to 0. So again, so gravity is going to be like vel.y minus equals gravity, right? Because you don't multiply or anything, you're just losing a certain amount of velocity every frame. So yeah, I think we're good there. And actually, we're gonna have to multiply this by our delta time, which means our gravity is probably like 9.8 will be too small, kind of thing. But again, we'll play with those values when we get there. And I guess that's it, right? Just those are the only two rigid body specific values. Everything else, all of our other pointers are going to be equal to null at this point, until we call our rigid body. Oh geez, rigid body initialize, and we're going to pass in. Okay, so we have float friction, float gravity, vector 3 pointer to pause, vector 3 pointer, or sorry, float pointer to rot, vector 3 pointer to scale. I think that's it. Is that correct? Yeah, I don't think it's complaining. So, yep, that's it. And in this case, we're going to say friction equals underscore friction. Gravity equals, oh geez, gravity. And then we'll have pause equals underscore pause, rot equals underscore rot, and scale equals underscore scale. So that's pretty much it on that side. Just these pointers are now going to point to whatever pointers we passed in, which means we'll actually be able to either modify or get the values of our sprite when we call the initialize method. So now we want to do our update method, right? Rigid body update. And our update method, so at the start of every frame, what do we want to do? I guess at the end of every frame, we want to say, we want to modify the position, right? So now we can't just say pause plus equals whatever, because pause it's a pointer to a vector 3. So we have to dereference the value first, right? So star pause, and then we can actually modify the contents of that pointer, so the vector 3 that it actually points to. So we can say star pause equals star pause plus vel. So the last thing we want to do is add our velocity to our current position. Now, obviously, we haven't calculated anything yet, but this is kind of the idea here, right? And our velocity, actually, we have to multiply. Will be vel times engine get delta time, and we need to include our engine. Just here is fine. Oops, include engine.h. So there we go. So now we're going to take the velocity, multiply it by our delta time, because we always need to, and then we'll add that to our current positional value, and then set our current positional value equal to that. Okay, so then the first things we want to do before we calculate anything else is take our current velocity, which is going to, again, it's going to be different every frame, right? As soon as we add a force, our velocity is going to get bumped up to something, and then it'll eventually die down given our following values, right? So vel.x, like I said earlier, times equals friction, and then vel.y plus. So let me see. Velocity y is increasing as we go up, so we do want to minus equals our gravity. Yes, right? Velocity, negative velocity means go down. So yeah, so we should be good there. And I guess that's all we want to do, really. We want to update gravity, update the friction, and then update the position. I think we're good, yeah. So that's it. So then the last thing we want to do is render, Rigidbody Render. Oh, and this takes vector 3c for color. So here we're actually going to write like straight up rendering code, just like in our Sprite, I guess. So the first thing we want to do is, again, GL load identity, if you remember that. Then we want to translate, so GL translate F by our position. So if we have to actually dereference our pause, and then, well, actually, so we do it two ways, right? We can dereference our pause in brackets, and then we can call .x on it. Or we can just do dash arrow, right? So pause dash arrow x, pause dash arrow y, and pause dash arrow z, which is hopefully 0 or 1. I don't think it really matters unless it's like greater than 10 or whatever we set our viewport z range to be. So we'll translate that. That's fine. We can then rotate. So GL rotate F by our rot, and in this case we'll have to just dereference the rotation. For the angle, and then again 0, 0, 1, we only rotate about the z-axis, which is what sticks out of your monitor, and then GL scale F by scale dash arrow x, scale dash arrow y, scale dash arrow z. Cool. So we'll do all of that, and now we're ready to render. And again, it's going to be very similar to our sprite rendering, right? Except that instead of rendering a sprite, we're going to render some lines. So this is basically what we're looking at here: texture, .get width, texture, .get height. So I guess that means the Rigidbody also needs to know about these guys, right? Width and height, if we want to be able to draw it properly. So what can we do there? I guess we can just okay, so our Rigidbody can now have, I guess, vector 3 pointer to size, right, which we'll pass along. So we have a scale, and then we have a vector 3 star size, right? So we keep track of the size as well. And then we'll say size equals underscore size. And then, okay, then we can use the size here. Okay, so let's just finish this up, and then we'll go back to Sprite and actually give it a way to return its size. But actually, I guess we're basically doing this, very similar to this. And notice we don't enable or disable these guys because we're not binding any textures. We don't want to do anything like that. Now the color is going to come in. We'll keep alpha as max, and we'll do c.x, c.y, c.z for RGB. And then instead of quads, we'll do GL underscore lines. And it works basically the same way. You just give it vertices. So we don't have these text chord calls because they're irrelevant because we don't have textures. So we just give it vertices. And sometimes I like to put these guys like this. So you can kind of tell begin, end, and it kind of separates itself. And actually, I didn't do that here. I do like to do this, just makes it a lot easier to see the begin and the end, and then the stuff in between. So yeah, I'll do that. And again, so again, instead of, so 0, 0 is fine because we've positioned it and we've rotated it and we scaled it and we set the color. So we're going to give it vertices now. So 0, 0, instead of texture.getWidth, it's just going to be size.x, or sorry, size-arrow-x. And this is going to be size-arrow-x, size-arrow-y. And this is going to be size-arrow-y. Perfect. So 0, 0, x, so width 0, width height, 0, height. And I guess that's it. That's all we gotta do. We just update the colors. We're drawing lines about these 4 vertices. So I think we're good in terms of our render for a Rigidbody. Now what's left is the add force, and the add force is very simple. Void Rigidbody add force, and our force is going to take, sorry, our function is going to take a vector 3 called force. And we're literally just going to do val equals val plus force. Oops. Plus force. And now we could multiply delta time here, but again, because we do it here, given our velocity, we only have to do it once. If we do it more than once, we're gonna get a much different value than what we want. So we'll add a real force, and then when we're modifying the position, we'll multiply it at that point. Which I think makes sense. We do all the calculations with the real force, the real values, and then we never actually modify velocity to be a tiny value because of delta time. We actually only add whatever we need to add for the velocity based on this guy. And because of this, x will get smaller and smaller, and y will will get bigger and bigger on the negative y-axis. So I think that's it. Should be good to go. Now, again, the sprite needs a way to return its size, right? Which is, I guess we don't really have like getters for these guys, right? So we should probably do that. See, what's the best way to do this? I'm trying to think, because we can return pointers to its values, but then anybody can access them. Now, do we care? How much do we care about that? Oh, well, we can just return the actual values themselves, right? Like, I'm trying to think of what the best way to do this is. I guess, well, I guess if we inherit from both Sprite and Rigidbody in a new class, it will have access to them if they're protected, right? So maybe that's the way to do it. If we go, yeah, I think that makes the most sense, because we don't want to expose this pointers to these private values, otherwise people can change them, right? So I think that is what we should do. So let's see if that makes sense. So protected. So now anything that inherits from Sprite can access these guys, which I think makes sense anyways. Same with the Rigidbody, so we'll go protected. And so yeah, we should be able to set these guys now in our new class that we create, because we're going to be able to access both things. Oh, but that's weird though, because then they're going to have the same name. Right, because I'm thinking like diamond inheritance almost. Well, I guess it'd be more triangle inheritance, but you know what? I don't know if I like that with the name clashing. Like, I guess I could change the names here, but that kind of gives us it's kind of limiting, isn't it? So maybe instead of inheriting from these guys, like a new class will just have a Sprite and it will have a Rigidbody. And then with that way we'll just make getters, but maybe that's not a big deal. I don't know. It's kind of I'm going on the fence. Like, it doesn't really. It's really just based on what we want to do. I think I like the latter better, meaning a new class just has a Sprite and has a Rigidbody, and it can expose those, I guess. Let's go with that for now, and we'll see if we want to, if it doesn't work out, I guess. So here we're gonna want to return. Yeah, I guess we'll want to return vector pointers, vector 3 pointer, called get pause. Get rot, get scale, get size, right? And then float pointer, and we should probably keep size like this, and we'll set it up based on the texture, and then we'll just do that here. So yeah, I think we'll do that. I don't think I've convinced myself just yet, but so we can return reference to pause, return a reference to rot, return a reference to scale, return a reference to size, and then here you say size equals vector 3 0. I wonder if it's scale here, right? Scale equals 3 0. Oh, I guess actually we want the scale to be 1. Size can be 0. That's fine. Scale can be 1. Size. In this case, won't be 0. In this case, we can say size equals vector 3, and we'll pass in. So now we can do texture dot get width. Oops. Texture dot get height, and we'll pass in a size of 1 for the Z. And these guys are ints, so we're gonna lose precision or whatever it's gonna complain about. So we'll convert these guys to floats. So their size, and we'll do the same thing here. Position, scale, size, right? So now we have size, and we're returning size, or reference to it for the pointer. So I think that will set us up properly. So now, and then our initialize sets these guys, and we would never really care about pulling these guys, right? At least not for now. So, okay. Alright, so here's where the separation between engine and game code comes in, right? Because we have a sprite, we have a Rigidbody, but we can't define something that pulls both in without getting game specific. So outside of our engine folder, I'm going to create a new folder called, oh geez, I'll put it outside, there we go. And let's call it Flappy Twitch. If that's the game we're making, we'll go Flappy Twitch. Is this within the engine folder? No, it's not. Okay. Okay, sure, Flappy Twitch. And inside of here, we'll create our flapper. Let's call it a flapper. This is basically our game player, or our game player, our actor, right? Our game object that we control. We have a flapper. So that way we don't define if it's a bird or a plane or whatever, right? We can make it whatever we want based on the sprites. Okay, sure. So if and def Twitch flapper, define it. And if flapper, oops. Okay, so we have a flapper. It's going to include engine graphics sprite, and it's going to include engine physics Rigidbody, and it's going to have both a sprite and a Rigidbody. Call it RB, and we'll have a flapper, new guy. Oops. New constructor. Then we'll have flapper that takes in a sprite, just so that we don't have to redo everything, right? Sure, sprite, and we know our flapper is going to need a rigid body, so we can do that here. That's fine. Rigid body RB. We'll set them equal to. Okay, and then I guess we'll need a void update and a void render, where it will literally just call the update and render on either of these guys. Okay, I guess this is good, right? So let's go include flapper. Oops. .h flapper flapper nothing. So do nothing, right? These are both of these classes have default constructors, so we don't need to do anything here. Flapper takes in a sprite underscore sprite, takes in a rigid body underscore RB. So we can say sprite equals underscore sprite, RB equals underscore RB. Right, that should be fine. And then, yeah, that's it, right? And then we have our void flapper update, which is going to do sprite.update, and then rb.update, and then void flapper render, and then sprite.render, render, and then rb.render. We'll have to pass in a color, so vector 3. Let's make it red. Actually, that plain's red, right? Let's make it actually let's make it black. And we render both things. And is that it for our functions? Now I just realized though, right? Our rigid body, if we're passing them both in, do we need to pass a rigid body in, or do we just need to pass a sprite and we can define the rigid body within here, right? Because then this means that whoever creates a flapper needs to set both of these guys up. Set this guy based on this guy. Yeah, I don't think I like that. I think that's too much work for whoever calls this guy. Even the sprite, maybe like this should just, well, maybe this inherits from sprite but has a rigid body. We can deal with defining that further to what makes the most sense as we go on. For now, what I'm going to do is I'm going to make whoever creates a flapper create a sprite first and then assign it to this guy. And then I'm going to set up the rigid body based on that sprite, right? So RB is already equal to because of our default constructor, it's already equal to well, this. So now we can call initialize on it. So we can say rb.initialize, and we'll pass in a friction, which we'll set equal to 0, gravity, which we can set equal to 0 for now. We'll see change later. So pause will be underscore sprite dot get pause, right? Sprite dot get rot, sprite dot get scale, sprite dot get size. Right? That makes sense, right? So we initialize it, all 4 things, then the rigid body takes care of the rest. Then we update and render. So, okay, I think if we have 7, we should be good. Some convert guys, something, yeah, that makes sense, right? These guys are ints, so we'll have to convert these guys to ints. Int. It's fine. F7. Alright, so I think we're good. Now, in our twitch.cpp, instead of creating a test sprite, we'll create a test sprite, we'll set it all up, and then we'll create a flapper, right? Now, flapper is not part of our engine, it's part of our Flappy Twitch. There's the flapper. Now, I didn't have to make a folder for this guy since this is the game project, but whatever, just for clarity's sake, right? So, Flappy Bird, flapper, and then we'll create a flapper, call it player, I guess, equals, or actually we just do this, and now what does it take? It takes both a sprite and a rigid body, right? Or just a sprite, so test sprite. So it takes test sprite in, and now we have a valid player, right? Now we don't want to actually do anything to the test sprite. Instead of update, we want to do player. Yeah, see, this is why, because I don't have to say player.sprite.rotate by. Yeah, I think what makes the most sense is for our flapper to inherit from Sprite so that it is a Sprite, so we can do all of this to it, and then also have a rigid body that handles itself within the class. Just for like simplicity's sake and just because of our time right now, we're probably just going to create some getters, and then rigid body get RB, just for now. We'll have to come back to this. But, oh, okay, so now our Twitch we can just do, so yeah, again, we'll have to do player.getSprite.rotateBy, player.getSprite, 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 and then player.render. Begin render, player.render, end render, and I think that is enough to create our flapper. So if we run this, that's 7, right? Should be fine. If we run this, nothing should have changed. Actually, a couple things changed. We can't move. Our lines for that rigid body are drawing in the wrong order. Okay, so why can't we move? Button down, .getSprite.rotateBy. So we're probably doing, oh, geez. Okay, yeah, so this needs to be a reference to these guys, so that we can actually modify them, because right now we're returning a brand new sprite really on the other side. That is, we're getting called on, but it's not affecting anything, right? So we're going to return references to these guys, so that we should be able to do that to them. So there we go, moving works now. So yeah, that was an easy fix. That's my bad. And okay, so everything works. Now our lines are not drawing properly for the rigid body. So what's going on? Bottom left. Oh yeah, of course, right? So lines work a little differently than textures, right? So we're going vertex to vertex, and then vertex to vertex, right? So here we're drawing bottom left to bottom right, then we're drawing top right to top left, right? And that's it. We're only drawing 2 lines. So we actually need to start. So we start bottom left to bottom right, then we need bottom right. These are grouped in 2s, okay? So we go bottom right to top right. Then we go top right to top left, and then we go top left to bottom left. Yeah, that makes sense. So yeah, that's the way lines work, is they're grouped in 2s. So you go start vertex and end vertex, and it'll draw a line between the 2. So we need to basically double up on these guys, because we're starting at the point at which we ended. So we have 5. Now we should see a box. There we go. That's great, eh? So that is a box. That's our rigid body. That's where our rigid body is. And it is updating itself based on our sprite. So to actually see it change, let's go into our flapper, and let's give it a friction value of 0.5f, 0.8f, so it drags a little longer. So what we should see here is I can move it. So another thing, right? Our move left and move right is moving the sprite directly. We instead need to be adding forces. So again, instead of getting the sprite and rotating by, well, it rotates fine actually, because we're not going to do forces for rotation, at least not right now. But here, instead of move up, move down, move left, move right, so we're going to go away from moving the sprite directly and go through a rigid body instead. So let's get our rigid body, and let's add a force, vector 3, and to move left, or sorry, this is up. So to move up, we're going to add a force of, I don't know, this is arbitrary right now. Let's say 200. We'll add 200 units of force upwards when we press W. And again, only when we press it. Now, actually, this is as we're holding it. So we're going to be skyrocketing it basically, because every frame we're going to add another 200. Let's make it 20. let's see what happens. So there, I added a force, and because we have no gravity and we have no vertical friction either, it's just going to keep going. So let's give it some friction, some gravity. Well, actually, let's do left and right first so we can see friction. S is -20. A will be -20 to the left, and D will be -20 to the right. So we'll add these forces, and okay, great. So how much? We have 0.8 friction. So if we run this, I'm just gonna hold down D for a bit. Oh, we're going the wrong way. Sorry. So let me just close these guys we're not using anymore. That's good. So A is left, which is negative. Actually, that makes sense, right? Negative. Oh, whoops. Negative and positive. Okay, so I'm going to add a force to the right, and I'm constantly adding them. Velocity is still, or friction is still happening. As soon as I let go, we see it slide for just a bit, and it gives you kind of that sense that you can kind of tell. So I'm going to let go in 3, 2, 1, let go, and you can see it slide a bit. So what we can do is give it more force. Let's say 200. It's going to be a lot, right? But we'll see the friction in play. So you can see it slow down, right? Now another thing we can do is, because even 0.8 should be faster than that, right? Like 0.1 should be, we almost not see anything. Oh, actually, oh, okay. So it's acting on the amount of force we're getting because, well, yeah, because that makes sense, right? Because we're slowing ourselves down almost to full stop before adding force again. So if we go 0.999, for example, this should slide. Oh, geez, yeah, there we go. So it slides a lot. It almost never comes to a stop. It probably never will. So let's just say 0.9. Yeah, so that's, you can see it slide. You can see it slow down there, which is good. And then we still have up and down. And remember, these are never, there's no gravity, so I'm finding the 0 by adding forces both up and down, and they're actually where it's 0. So if I press up, it'll never come back down. We see our gravity or our friction work. So okay, let's bring this back to an 8. And we have to, because this is acting on it in every frame. Oh, I know what we need to do. So once we apply the velocity, we need to reset our velocity to 0. Because then we don't want friction to dictate how fast we move, right? So if we reset our velocity, then when we add a force, so we can add force, the next update will, okay, so let's do, okay, so we're going to move this around a bit. So we're going to do this. Let's see. So if we call add force, we want to add the full force, then have this apply. Oh yeah, no, unless we want to do it this way. In this case, we'll have this apply just for that one frame. We'll add this, and then we'll let go. So if we do this, so up and down move a lot slower, right? Because we have 200 on the other side. Let's make this 0.99 again. Let's just play around with these values. Yeah, no, that's not gonna matter, right? If we set it to 0, so that was a silly thing to try. Okay, that's fine. Let's just leave this as is for now. We'll give it gravity of some sort. So flapper will give gravity, let's say of 10, I guess. And we're, oh, okay, so here's another thing, right? 10 gravity is a little weird, generally negative. So if we add gravity, we can give it a -10, which I think makes more sense. Now it should always be falling unless I hold up. So now I'm holding up, then it falls down back to gravity. And you can see that velocity take place, right? You can see how it eases into that curve. and slowly comes back down because every frame we're continuously adding that gravity to it. And yeah, so we're constantly adding force, then we let go, and then we basically gravity takes over, and eventually starts to fall down. So now we can move it up and right and left at the same time, and if I let go, it's just gonna fall. So there we go. I think we have pretty neat thing to go with right here. So I think that's where I'll end off. I hope everyone enjoyed that. Let me go back to the comments real quick and see. Yep, looks like everyone's okay. So we should be good. Next week, what we'll probably end up doing is either collision or maybe perfecting the input for the flying, because right now we have WASD, we have rotation on the clicking. Like maybe what we could do next week is basically increase what our flapper actually does. Actually, you know what we'll do is we'll make this be a sprite. It'll inherit from Sprite, which I think makes the most sense. It'll have a rigid body that it assigns to its own, it handles itself independently, but it is a sprite. The update method would like add rotation, right? Like I can even do that now, right? We could do something like go sprite dot rotate by, let's say 10 degrees, right? So now it's more like Flappy Bird where, whoops, negative 10 degrees. So where you kind of dip and then you kind of rotate, and then as we press up, we should add a huge force upward and then reset its rotation back up to like positive 45 degrees or whatever. So I think maybe we'll do that next week. We'll focus on setting up the actual input for what our bird slash plane slash flapper is going to behave, the way it's going to behave. So yeah, I'll leave it off there. I think there's nothing else. So thank you guys for coming out again, and we'll see you next week.